Good morning, students. Today's topic is photoelectric effect. What do you mean by photoelectric effect? Means when a light of suitable frequency fall on the surface of metal, then the electrons are ejected out from the metal surface. This phenomena is called as photoelectric effect, and the emitted electrons are called as photoelectrons. Now in 1887, Hertz performed an experiment in which the electrons are ejected from the surface of metals. Where certain metals like potassium, rubidium, cesium, when a beam of light is fall on this metal surface, then the electrons are ejected out from the metal surface. These ejected electrons that are counted by a detector, to measure the kinetic energy of the electrons. Detector is used to count the electrons to measure their kinetic energy. This is noticed by the ammeter. Then what are the following observations takes place by this experiment? When a beam of light fall on the metal surface, then electrons are ejected immediately. Second point, the number of electrons ejected, that is directly proportional to the intensity of light, means brightness of light. Third point, for each metals, there is a minimum frequency below which the photoelectric effect is not observed. This frequency is called as threshold frequency. It is denoted by mu naught. These are the observations. This threshold frequency, it is denoted by mu naught for each metal. There is a minimum frequency below which the photoelectric effect is not observed. This is called as threshold frequency. It is denoted by mu naught. Case number 1. If the frequency of light is greater than threshold frequency, then the electrons are ejected out easily with certain kinetic energy. But if the frequency of light is less than threshold frequency, then no ejection of electrons takes place. Means no matter how long it falls on the metal surface or how high is its intensity, it does not depend on these values. So the kinetic energy of these electrons increases if the frequency of light used increases. Means kinetic energy is directly proportional to the frequency of light. When a photon of sufficient energy strike on the electrons in an atom of the metals, it transfers its energy to the electrons during the collision, and the electrons is ejected without any delay. Means this process takes place. It means greater the energy possessed by the photon, greater will be the transfer of energy to the electrons, and kinetic energy of ejected electrons also increases. So we can say that the energy of striking photons is equal to binding energy plus kinetic energy of ejected electrons. Binding energy means the energy which hold the electrons to the metal surface. Or we can say that the kinetic energy of ejected electrons is proportional to the frequency of electromagnetic radiation. The energy of striking photons, that is h mu, is equal to h mu, and the minimum energy required to eject the electrons, that is h mu naught. This is the kinetic energy of striking photons. This is the minimum energy required to eject the electrons. It is also called as work function. This one, W naught. And the difference in energy, that is h mu minus h mu naught, that is transferred as the kinetic energy of photoelectrons. So by the help of this, we can easily find out the kinetic energy of ejected electrons. Photoelectric work function is W naught, means the minimum energy required to eject the electrons. This is W naught. W naught is equal to h mu naught, means kinetic energy of striking photon is equal to binding energy plus kinetic energy of ejected electrons. Kinetic energy is equal to half mv square, where me is the mass of electrons moving with velocity v. So this is the formula of energy of striking photons. h mu minus h mu naught plus half mv square. By the help of this, we can easily find out the energy of ejected electrons. Now take one numerical problem. The threshold frequency mu naught for a metal is 7 multiplied 10 raised to power 14 per second. Calculate the kinetic energy of an electrons emitted when the radiation of frequency mu, that is equal to 1 multiplied 10 raised to power 15 per second, hits the metal. How will we calculate the kinetic energy of an emitted electrons? Mu naught is equal to this one given, mu is also given, frequency of light. Kinetic energy is equal to half mv square, that is equal to h mu minus h mu naught. H is common because formula is h mu is equal to h mu naught plus half mv square. Putting this value, after that kinetic energy we have to calculate now. H value is 6.626 multiplied 10 raised to power minus 34. Mu value is given, mu naught is also given, and after calculation this is the answer, 1.98 multiplied 10 raised to power minus 19 joule. Unit of kinetic energy, that is joule. So we can easily find out the kinetic energy of emitted electrons by the formula. Thank you, students.